the Kemetic, the people of color. We all think that the way time came to us, the way we perceive time, it seemed to be a given, it's like within a human being to, know something about time. But we're going to try to talk a bit about the philosophy, behind it. And you will see that there's a lot that is questionable in that train of thought. How do we know that time exists? How do we know that time passes? How do we know? You see, these are like questions you feel like, no, why should somebody ask this question? But let's try. How do we know time? Okay. Let's imagine within ourselves or within our surrounding how we come to perceive time. Because let's face it, it looks like it's very, very elusive. It's very, difficult to perceive time. Why is it difficult? Because most of the things we base on to perceive time are really external. Let's face it, they are even extraterrestrial. What I mean extraterrestrial is that, okay, maybe we come to understand that a day today exists because, hey, we see the sun rise and set. We look in the sky, we see, other celestial bodies move. Because face it, if we were not seeing them, that we have no way of finding out that even the earth rotates. Now, if they stop moving, hey, where will our idea of time be? How would we conceive time? How would we say, hey, time is going on? Hey, face it, most of our concept of time is very linear, in a line. It's because we think yesterday existed, we see today, and we expect tomorrow. Now, if suddenly we take that out of the picture, because the celestial bodies we base on to make these assumptions are taken out, how do we perceive time? Where will time come from? Is it making sense? Can you get me on that? Okay. So you see, that becomes a very, very interesting issue. Maybe it's because really what we were calling time, maybe we will have to even reassess that. Because the sun doesn't give us time. Because even the stars don't give us time. They just move according to their cycle. So what we mean by that, what we really call in time, doesn't exist as an entity that is not linked to our perception of something else. So time for us is very simple. It doesn't exist because the celestial bodies we're watching, they don't offer us time. They don't hand us like in a panel, oh, this is time. The sun rises. We just talked about the fact that even the rotation of the earth is inconsistent. It doesn't go like how, we learn to think like, it's like a car moving on 20 miles per hour. Won't go beyond that, won't go below that. It doesn't work like this. Okay, if the earth's rotation shows inconsistencies, and we just say, well, our notion of time is only based on the celestial bodies and their movement. And the celestial bodies, they're not handing us the time, but they hand us one thing, the notion of a cycle. What we perceive in the universe is rhythm. But what does this rhythm have to do with us? Well, come on. We see rhythms. A rhythm, the rhythm of the universe can only have a meaning to a human being if we can find it within the human being himself. But for now, we're having a problem here, because, we can try to understand this only, if we have the assurance, that notion of rhythms, there is a space where we can place a human being, because then that will make a human being a universal being. It allowed us to become aware of our place in space. If we have our place in space, then it gives our life some understanding. We understand what our life is. Then we start doing our search. We are doing our search. We all observe so many rhythms and like this. But then there's a notion of space that comes into play now. Let's see. We try to say, okay, a human being's life. We need something. We need something we can look at. Something that we can, to guide us through life. But there's so many rhythms. We started by checking the ones that we see more often, which is mostly the sun. Okay. But we have a problem with the sun, astronomically speaking. Because when you watch, when the sun finishes its rhythm, you can't call it a cycle. You want to understand that the rhythm, that's different than a cycle. Because to have a cycle, the sun will have to rise the same place you saw it yesterday. You get the point? Because if not, it looks like a spiral, Today it rises here, tomorrow it rises there, tomorrow it rises there. So you can't call it a cycle. A cycle will be when it goes like this and end up the same place that you saw it the first time you get it. So the cycle is complete. So, but with the sun, you would have to wait over 56 years to have the sun rise in the same exact position. So, wow, very interesting. Which means if we really have to, if we call a sun, the cycle of a sun, a day, which means I'm not a day old yet. You see, that causes a very, very serious problem to a human mind. If you have to wait over 56 years to have the sun rise in the exact same position, astronomically speaking, it's impossible to have to set a calendar on that, because that's comes another problem with the sun, because that depends on the position of the sun in a universe. Sometimes it goes down to 54 years, and sometimes, like according to the Kemetic astronomy, sometimes it can go up to 63 years to get a sun to rise in the same position according to the Earth. It just doesn't work to make a calendar based on that, unless you want to cut corners like how religions and all do. Then it's not a knowledge anymore, you see. So we move to the other celestial body that we see, the moon. The moon, for exactly to have a moon, we call it in the same knot. The moon gives us more room because we observe eclipses. We see the eclipse, the sun, the moon, and all this. So if we could use one of the eclipses as a line to start counting, that would help till that eclipse happen again. Then we could say, well, we have one cycle. But to have the moon in the same exact position, you would have to wait 18 years. And exactly that will be 11 days. So, like if we base on the moon cycle, I will be 3 months old, 3 months old. It doesn't work. It doesn't work. So astronomically speaking, these are the main two celestial bodies that we see every time, over and over and over, but it doesn't work to base on that. So what our fathers did, our ancestors did, is to look and study every cycle and see which cycle offers the precision we need, so that we can advance in our search or quest for knowledge. So they came up, they found the cycle of Sotis. I don't know how you guys will write it in English, so probably Sotis. Yeah, Sirius or Sotis, the same. Yeah. 1,460 years. $1,460. Because now the problem, the two planets, the two celestial bodies that we could have as a direct reference is not working for us. So now we will have to look for what we call a sidereal positioning. A sidereal positioning is a position not that you see directly, like how we see the sun or the moon. A sidereal positioning include a third part, which is like that will be like a position like Sotis, and then the sun and the earth. So we have this notion. Is it making sense up to now? Are you guys following? Okay. So, then we have this issue. Remember, up to now, we just destroyed the idea of time. You remember that, right? We replace it with the notion of rhythm. Because time, we can't build the notion of time. But when you put all based on the rhythm, one rhythm is just equal to another rhythm. One might be slower than the other and like this, but we have the notion of something that introduced this notion of a movement, without it being necessarily a cycle. You see, just like, how you call it? Well, put it this way, it's really that notion of rhythm that's gives us a notion of movement. Some rhythms don't allow because they are too short, and some allow a lot to happen within, they accomplish. Sorry. So now we talked about this Sotis cycle here. The Sotis cycle appeared to be way, way, way longer than that. 56 years and 18 years. But we also notice one thing, is that whichever part of the planet, on Earth, where you notice the presence of this star, it happened to trigger rainy seasons. You see, we notice that for pure observation. So, like for example, in every part of the planet, when the Sotis star, where, because depending on the positioning of the planet, you get the rainy seasons when you have, that star, especially on the horizon, when the sun rises close to it. You see. So, we notice that fact. And we notice many other facts. Okay, you have to understand what a year is. You remember how we've been breaking this, the notion of the cycles. The years don't work. The sun, the cycle of the sun is not working. The moon and all this don't work. So it's the notion of a year. What we call 360 years, 65 days, is not really a year. We just call it a year because there is a seasonal cycle in it. Winter, summer, spring, autumn. So because, it fits in that, we choose to call it a year. But in Kemet, that was we were calling the farmers' years. That's what farmers go by, because it rhythm the production, the period for inundation, the period for, plowing and all this. But astronomically speaking, the year is 1,461 day, which makes it exactly 4 times this. You see, that's why every 4 times that they decide, let's add 1 day, because astronomically speaking, this is a year. So by adding 4 times this, you come short 1 day. Since you come short 1 day, you add that day one way or another. And why a year is this long? Now that takes us to the cycle of Sotis, you see. Because you will notice that on the Sidereal Calendar, we explain one fact that, hey, I'm too young to witness it, but you will have to live at least, 2,000 years to notice it. But from the archives of our forefathers and like this, it's very, very documented that once every 1,461 years, the sun eclipses this star, the Sirius Star. From what they explain, that it creates some very, very huge disturbance of the energy on the whole planet, and it sets a new kind of. It's like one page of human history. It became clear that exactly, when the sun eclipses that star, that's what happened. So it becomes for us a cycle. So when you divide this, you see it's the exact same numbers here. So it becomes our way of monitoring that day. How many do you have to multiply to obtain that? 300 and what? Well, you know what I'm saying. Every day will represent 1 year. Every day will represent 1 year. But after that, the interesting thing is, then really that becomes the length of the year, 1,461 days. It becomes really the length of the year because the year has everything to do with monitoring that phenomenon.